Welcome to Monochemistry. We're going to talk about stoichiometry, and before we can go really into a huge amount of detail about stoichiometry, we really need to focus on an important concept, which is called the mole. And right now I'd like to introduce you to Amedeo Avogadro, the very ugly-looking man who you see right here. And as the story goes, he came up with the idea that atoms, which are unfathomably or ridiculously small, could be quantified. And not only that, but there's a certain number that allows us to quantify that. And eventually that number was described and discovered, and because he was the first person to talk about it, it was named after him. He unfortunately didn't actually come up with the number, but he did a lot of work around it. And that number is also known in today's kind of educational field as the chemist's dozen, because it allows us to do lots of different things with amounts in chemistry, which is very important. The story goes that they named it the mole because, as you can see, the mole and our friend here, Amedeo Avogadro, have a striking resemblance. Now, while that story is not entirely accurate, two things are for sure. This is one ugly dude and one very intelligent dude who came up with a very important idea or concept in chemistry. The magic number, Avogadro's constant, Avogadro's number, the mole, is equal to 6.02 times 10 to the 23 atoms, or molecules, or formula units. In fact, the mole can be related to any object if you want it to be, although it's not generally used outside of chemistry. If I wanted to talk about a mole of sneakers, I could say there are 6.02 times 10 to the 23 sneakers. Just how big is that number? Well, in fact, if you started counting one number per second, starting from the time you were born, 1, 2, 3, say you live to be 100 years, say you live to be 1,000 years, which is ridiculous, but say that happened, you wouldn't even get close to this number by going 1, 2, 3, 4, 5. Wouldn't get close. It just wouldn't happen. That's how big that number is. It's a ridiculously big number, but that's how small atoms are. Now, the cool thing about this number, if we keep talking about it, is that it allows us to quantify the periodic table. So look at the periodic table, find hydrogen. We know that the atomic mass of hydrogen is 1.01 atomic mass units. We also now know that if I had 6.02 times 10 to the 23 atoms of hydrogen, and this is the cool part, I'd have 1.01 grams of hydrogen. Take any element on the periodic table. Find the atomic mass unit, or the atomic mass, which is on the periodic table. Assume you have 1 mole of that substance, and you can say for certain that that same mass in atomic mass units is what it would be in grams if you had a mole. And that's very important in chemistry. But how do we use Avogadro's constant? Well, the idea comes in the form of conversion factors, which we've talked about in class. 1 mole of anything equals 6.02 times 10 to the 23 of that anything. Okay, so let's say I had 2.136 moles, and I wanted to convert that into objects, whatever they are. I don't know, eggs, sneakers, whatever, doesn't matter. Chemistry, we could talk about moles of carbon. What I would need to do is I would need to set the conversion factor. Now, the conversion factor would look just so. I'd have 2.136 moles of whatever. I put the mole on the bottom of the conversion factor so that those things cancel out. And what I would do then, I would multiply the number here, 2.136, times 6.02 exponent 23. Now, it's very important in your calculator when you type in Avogadro's number, you type in 6.02. You do not hit times 10 raised to the power of 23. You hit 6.02 exponent, or sometimes there's an EE button on a calculator, and then you don't type times 10, you just simply put the 23. That will give you the right answer every time. So what is the final answer to this question? Notice there are 4 significant figures here. You don't worry about, for constants like Avogadro's constant, you don't worry about significant figures. So you'd multiply through 2.136 times 6.02 exponent 23. And the final answer is 1.285 times 10 to the 24. That's your final answer. So it doesn't matter if you start off with objects or moles, you can use this concept right here in a conversion factor to solve for whatever you need to solve for. And that in a nutshell is the mole and how to use it very basically in conversions in chemistry.